Third video today on digital design. Today we will create a circuit, a digital circuit with what we have mentioned in the previous videos. I will also put the previous videos in the description below for those who do not understand what is happening here now, what we will do. We will create it from scratch, the circuit, like this. We will start from paper, truth tables, Boolean functions, and finally the implementation of the circuit with the components. But before we start, we will subscribe to my channel and hit the notification bell so that we receive the next videos and do not miss any. Let's see what the circuit will be. It will be a motor control. Yes, a continuous motor control. We will also create a digital circuit that will be able to rotate the motor right-left. It will have an error if any wrong manipulation occurs and an indication that it is functioning, and we will perform some operations. So let's assume that our motor is this one over here. What do we want to do? We want to create a box that will have two switches, two buttons at its input, and at its output, it will have 4 commands, which will control the right-left of the motor, a function indicator, and operations and an error, a buzzer at its output when we make a handling mistake. It should, of course, receive power supply, and what will happen now? When we press the first button, the motor will turn right. When we press the second button, the motor will turn left. When we press the circuit, both buttons will have the buzzer, the error. A small buzzer will sound. The operation indicator will be nothing more than an LED that will remain lit. And when we press a button, it will turn off. It will indicate to us that it is receiving power, and when we press a button, it will turn off, that we are performing a function. So let's create a truth table for this thing now that we have designed it here. Let's assume that the first switch is X, the second switch is Y, and the output, the functions, are the functions we need to produce. The first one we will name F1, the second F2, the third F3, and the fourth F4. I have said in the previous videos what functions are and what happens with them here, and how from here we will move on to the truth table. And then after the truth table, we will go to our circuit. Let's also create the truth table. Input with sound PES and functions F1, F2, F3, F4, and let's do it together a bit. Because we have two variables, x and pice, the combinations that can be made on the buttons, the commands, the maximum that can be done is 2 in the second, meaning we will have 4 horizontal columns and 6 vertical ones. And now let's go. If we don't want any that is currently pressed, we said it will work. The operation indicator light will turn on, the F1, so at F1 we will have an output in order for the light to turn on. And in all other cases, there is no need for the light to turn on. We will be at 0. We will do the same with the others. When the PES is pressed, the motor will turn right. So at F2, we will have only 1. When button H is pressed, the motor will turn left. So we will have only 1 at F3. And when both are pressed together, it will give us error F4. So it will only give 1 in the last one. This is the truth table of our circuit. And now let's quickly create the functions as we have mentioned in the previous videos. From the truth table, we will take each function separately, and we will create their Boolean expressions. For those who do not know or did not understand what we are doing, I explain it like this in the previous videos. They should also go back to the videos to see how this is done. We will take the minimum terms of each function, and we will create their Boolean expressions. And these are the 4 functions. And what do we see here now? That all these gates here are AND gates. So because they have the not in the middle, we have said these, and we see some terms, some variables that are emphasized, so we see the tones here. So we also have not gates, so they have, in other words, 4 AND gates, because there are 4 multiplication issues. Our products will be 4, so we definitely have 4 ANDs. And from the tones, because they are 2, our variables, 2 not stand for us. To build our circuit. So we will need, we said 4 ANDs and 2 not. Let's go quickly. Let's build our circuit with our gates. And I repeat, for those who don't understand, they can write me comments or go back to the previous videos to see it. And the final conclusion is that inside our box we'll have these two gates, connected as in the diagram we made. And let's go to see and summarize. What will we have outside this box like this? We will have said the switches, the two small buttons start and bake, and at the output will come out. At the first output we will have an LED. So at the second output we will have a relay that will give us the first rotation of the motor. In the second, at the third output, we will have a second relay. I designed the relay punishment like this over here. And in the final output, we will have a buzzer that will give us the alarm when we press the two buttons together. So now we are ready to build our circuit, theoretically always Y. We practically have two initiatives. The first problem has to do with the input, with the polarization of the input, basically, because the gates are electronic circuits. We say digitally, but in reality they are also analog. They are made from semiconductors, and they also have some internal leaks. I want to have clear inputs. That is, when we have 1 to have a tendency, and when we have 0 to have grounding, not to be floating, that is, because they have some internal leaks from the sum towards the inputs. And they get confused. They don't know if it's 0 or if it's 1. So we will use resistors here at the inputs, around 2 kilos, both in one and the other. And we will adjust them to have a clear 0. Here are their inputs. And when we close the buttock, they will be clear. The 5 volt that the input will finally receive. That's how electronic we are. Just as we multiply the transistors, we will multiply the inputs here too, as we increase the transistor bases. And the second issue is with the outputs. I can't remove components that pull a lot of current a lot now. Don't imagine we're talking miles per hour like this, so the relays won't work like this, as I have connected them here like this. The LED, it's okay, the buzzer will work too, because they are small, but the relays won't work like this. As I have connected something to the output, I will need to put transistors in between, like this. I will use transistors, I will connect them like switches, and they will drive the relays for me. Here will go the transistors. They will multiply, and they will lead me to the relays. And from there on, these relays will lead me to the motor. And here we conclude to the conclusion that we need both analog electronics, very much like digital ones. It is a combination of the two. I can't work digital electronics if we don't have the analog ones like this. So after these tips, we can go to construct our circuit to see it as well. Anyone can build this circuit like this. If you don't want to make it from scratch, you can copy it. But it would be good to know the process to be able to create special circuits. This specific circuit can be used with other gates in front and perform other functions. The same circuit tile, in reality, is a decoder. Those who know digital will see it from the truth table. And there is also ready just a chip like that. There is a chip that has a decoder inside. Basically, it has 2 decoders inside that perform the functions with what we have created now. Well, let's go for a test. I have connected 3-phase power. We see that the indicator light turns on operation. We press the first button. The indicator light turns off. The motor turns to the right. Press the second button. The light goes off. The motor turns left. Press both. The light goes off again, and the buzzer works. So our circuit works correctly. As we designed it, as we made the truth table, as we made the functions, as we finally implemented it, it's great. It will do what we want it to do. With all the combinations, no matter what we do to it, it will do what we have designed for it to create. So that was the video. If you liked it, like comments below. Why do you want questions and notes? Let me tell you. Those of you studying digitally, I believe I gave you some answers from your questions. We went from paper to the circuit. And good continuation to all. Have a good time. Hello.